Okay guys, we're going to do the very last problem in 6.7 and we are going to use our graphing calculator. So if you don't have one already, please pause it and get a graphing calculator. Okay, I'm going to assume you have your graphing calculator now. So here's the situation. We've got the height in feet of a golf ball hit into the air is given by h equals negative 16t squared plus 64t. T is the number of seconds elapsed since the ball was hit. So we're going to graph this on our calculator. So go ahead and go to y equals so we can put in our function. And our function is negative 16. So make sure you're using like a regular calculator down here for the negative 16. And then of course we don't have t. Well, actually it does say t, but it comes out as x squared. And then we're going to do plus 64t or x, whatever your variable is. Okay, now we want to set a window. Your window is most likely going to be set different than this. Sometimes you have to mess around to find a window, and we'll talk about that another time, but right now I'm just going to give you a window. So your x minimum is going to be 0, and your window is what part of your graph you get to see, because your graph goes on forever in both directions. Your x max is going to be 4, and this actually tells us that. We want to see on our calculator between 0 and 4 for x. Then we're going to keep our scale as 1. We don't want to go below 0 because we're talking about a golf ball hit into the air. If we go below 0, we're talking about below ground. And then we're going to go to 75 because it'll give us a nice picture. Now, go ahead and graph it. And that's what our parabola looks like. I'm not going to draw the graph because we have a graphing calculator, so we're not going to draw it. Okay, what is the maximum height of the ball? Here's the cool thing you can now do. We're going to let the calculator do some calculations for us. So push second, and then see how this up here under the tray says calc. So we're going to do second, calc, and then we would like it to find our maximum. So we're going to push 4 for maximum, and then it wants us to give it boundaries. So my left bound, I'm going to do a little bit left of my maximum, and for my right bound, I'm going to do a little bit right bound of my my vertex, and then I press enter, and it tells me that 64 is going to be my y coordinate, which is how high it is, so that's what I'm looking for. So it goes 64 feet. So my vertex is 264. And at this point it says how long does it take for it to reach its maximum height? That's going to be 2 seconds. The time is 2 seconds. Okay, how long does it take the ball to hit the ground? So that's over here where it hits the ground. And let's see. Okay, so this one we can pretty clearly see. It goes at 4. So 1, 2, 3, 4. So I'm going to put 4 seconds, but let's say that we had a graph that was not as pretty. You could also find your 0 or your solution. So we go to second calc, and then it asks us to find 0. So we put in 2, and then you have to do a boundary because there's 2 zeros, otherwise it won't know which one you're talking about. So we would do a left boundary somewhere to the left of my 0. And then I keep going until I get to somewhere to the right, and then it tells me that 4 is when y equals 0. Okay, so this one, how many seconds is the ball more than 48 feet up in the air? This one, I'm just going to go ahead and trace, and I'm going to trace until my, where is it? Okay, hang on, I'm going to go back here. I messed up my window somehow. Okay, my minimum is there, my maximum is 4. Okay, that's better. So now I'm going to trace it, and I'm going to see when my y is below 48. So I'm just pushing my arrows here. So you can see my y is getting close to 48. It just went below. My x, 0.97, 1.02. It looks like it's close to 1. And then I can go over here and I can do the same thing, looking at my y, seeing where it's 48. Okay, so it's close to 3 on this side. So I'm going to say between 1 and 3 seconds. And then here, it wants us to write an inequality. So when t is greater than 1 second and, whoops, less than 3 seconds. If this said exactly 48, that would be 1 and 3, so we would put the little or equal to on that, but we're not going to. All right, please write down anything that you don't understand and we will talk about it in class.